Hello, I am Baviskar. Today's topic for presentation is effects of climate change on global food systems. So let us now continue with the presentation.
So, what is climate change? Climate change means long term shifts in temperature and weather patterns. While the Earth's climate has always changed naturally, human activities are speeding up these changes. Major causes include burning fossil fuels, deforestation. Now, why understanding climate change matters? Knowing how climate change affects food systems help us prepare and adapt for future predictions. For instance, impact on food quality and availability. Climate change can lead to poorer food quality and less food overall. And in global effects, problems in one part of the world can affect food prices and availability everywhere. So, understanding the climate change and its impact on food systems. Climate change is a big challenge for food systems around the world. It affects how much food we can grow and how good that food is for us. Here's how it is explained further. Rising temperatures. Higher temperatures can reduce crop yields and increase evaporation, leading to less water for plants. Changing weather patterns. Unpredictable rain can cause droughts or floods, hurting crop and livestock production. Extreme weather. More frequent storms and other extreme events can damage farms and disrupt food supplies. All these issues can make food more expensive and harder to find, especially affecting people in poorer regions. So, how climate change can affect globally? So, the following uh, climate change can affect ecosystems. Climate change can disrupt habitats, leading to loss of species and damage to coral reefs. In economics, it can damage infrastructure, disrupt food production, and cause price increases, hitting poorer countries the hardest. Human health, higher temperatures and changing weather can increase health problems like heat related illness and spread of disease. So, what is the way to move forward and tackle these issues? So, we need sustainable practices using methods that are good for environment and food security, adaptation strategies, finding ways to adjust the climate changes, global cooperation, working together across countries to address these challenges. So thus, by understanding and addressing climate change, we can help ensure that our food system remains strong and can feed the growing global population. So now let us see the impact of climate change on crop production. So first is the effects of rising temperatures. That means how heat affects the crops. For faster growth, higher temperatures can speed up how quickly crops grow, but this isn't always good. Crops like wheat and maize are particularly affected by heat. For example, high temperatures during the flowering stage of wheat or the pollination phase of maize can greatly reduce yields. Water and nutrient stress. Heat can also stress crops by increasing their need of water and nutrients. If these needs aren't met, crops yields can drop. In regional differences. In tropical regions, these areas may experience severe impacts due to already high temperatures and limited water resources. In temperate regions, we might see different effects with varying levels of heat stress depending on the specific climate and crops grown. Secondly, how the changes in precipitation patterns occur. In more droughts and floods, planting and harvesting challenges. Unpredictable rainfall can lead to droughts. Both of these conditions or floods, both of these conditions can disrupt when and how crops are planted and harvested. Water scarcity. Droughts can make rain-fed agriculture very risky. This is especially problematic in areas where people depend on this type of farming, such as sub-Saharan Africa. Third is extreme weather events. So impacts of storm and hurricanes. Crop damage. Severe storms and hurricanes can destroy crops with strong winds and heavy rain. Flooding can wash away topsoil and drown crops. Economic effects. The damage from these events can lead to immediate food shortages and higher food prices. In many developing countries, this can cause long term economic issues as agriculture is a main part of the economy. Long term consequences of these extreme weathers. Food prices and availability. After a storm or hurricane, food prices often rise because of reduced supply. This can make hard for people to survive. Food security. The destruction of crops can lead to long-term food insecurity. If crops are repeatedly lost, it can reduce the overall productivity of agricultural land and force some farmers out of business. So, in the summary of this slide, climate change affects crop production in various ways, including higher temperatures, changes in rainfall, and extreme weathers. These impacts can lead to lower crop yields, higher food prices, and greater food insecurity, highlighting the need for adaptation strategies to protect global food systems. So, continuing further, a research study by Zhao shows that the rising global temperatures have a significant impact on crop yields. As shown here, as per the graph, it indicates that as the temperature increases, the yield crops like wheat, rice, and maize are expected to decrease by 6%, 3.2%, and 7.4% respectively. Thus, these reductions are due to increased heat stress, accelerated crop development, and reduced growing seasons. Moving forward with the effects of climate change on livestock and fisheries. First is impact on livestock, which is caused due to heat stress, which further causes due to rising temperature, health issues, reproductive effects, productivity decline. In rising temperatures, climate change increases global temperatures, leading to heat stress in livestock. Heat stress occurs when animals can't cool down effectively, negatively impacting their health and productivity. Health issues. Livestock suffer from higher respiration rates, dehydration, and increased disease risk. For example, heat stress can lead to metabolic imbalances and cardiovascular problems. Reproductive effects. Elevated temperatures disrupt reproductive cycles, lowering fertility rates and affecting milk production in dairy cows and egg production in poultry. Productivity decline. Heat stress reduces feed intake and metabolic efficiency, causing lower milk yields and slower weight gain in cattle, and decreased growth rates and egg production in poultry. Second, impact on livestock includes regional examples. In United States, in hot states like Texas, heat stress reduces dairy and beef cattle productivity. In Brazil, due to high temperatures, affect beef cattle productivity, causing reduced weight gain and higher mortality rates. In India, extreme heat reduces milk production in dairy cattle and affects poultry, impacting the dairy industry. So, what are the adaptation strategies? Shade provision, use shelters and shade cloths to reduce direct sun exposure. Ventilation, improve airflow and cooling systems. Nutritional adjustment, alter diets to include energy dense feeds and provide ample clean water. Feed availability and quality. Climate impact. Climate change affects feed crops like maize and soybeans. Increased temperatures and altered precipitation reduce crop yields and nutritional quality. Nutritional quality. Elevated CO2 and temperature stress dilute essential nutrients in feed crops, leading to poorer livestock health and productivity. Continuing with impact on fisheries, in ocean warming, ecosystem changes like rising ocean temperatures disrupt marine ecosystems, affecting nutrient availability, oxygen levels, and habitats like coral reefs. Fish populations. Warmer waters cause fish species to migrate to cooler areas, disrupting traditional fishing grounds and alternating migration patterns. Species like salmon may face reproductive challenges if waters are too warm. Species decline. Some species may decline if they can't adapt or move. Coral reef fish are particularly vulnerable as reef bleach and degrade. Now, coming to the regional examples of this, Pacific Ocean. Tuna migrate eastward, impacting fisheries and causing disputes over fishing rights. In North Atlantic, cod and haddock move north, disrupting fishing industries in the UK and Norway. Mackerel expand into Icelandic waters, altering fisheries dynamics. In Indian Ocean, sardine populations decline due to warming waters and changing monsoon patterns affecting local fisheries. Understanding these impacts helps in planning and adapting agricultural and fishery practices to maintain food security and economic stability in changing climate. So, the data insights on livestock and fisheries as shown here illustrates the relationship between temperature rise and milk production loss in dairy cows. So, a study in United States found that the heat stress could result in significant loss of milk production in dairy cows, costing the industry millions annually. So, the graph shows the increase in temperature and the loss in milk production in dairy cows. Let us now look into the changes in agriculture practices due to climate change. First is adaptation strategies, and second is technological innovations. So, into adaptation strategies, first comes shifts in planting and harvesting times. Adjusting schedules. To cope with changing temperatures and precipitation, farmers are modifying their planting and harvesting times. Early planting. In regions with warmer temperatures and longer growing seasons, farmers plant crops earlier to avoid heat and drought stress. Delayed harvesting. In areas with changing weather patterns, delaying harvesting can improve crop quality and yield by allowing crops to mature under better conditions. In regions like United States, farmers in the Midwest are planting maize and soybeans earlier to avoid late summer heat. In the southern US, adjustments are made to harvesting schedules to manage hurricane risks. In India, farmers adjust planting dates for rice and wheat based on changing monsoon patterns to avoid water stress during peak heat. So, in adaptation strategies comes development of climate resilient crop varieties, which includes breeding and genetic modifications, which means creating crop varieties that withstand climate change impacts is crucial. Drought resistant varieties. Developing crops that need less water, such as drought resistant maize. Heat tolerant varieties. Breeding crops that can handle high temperatures like heat tolerant wheat. In Africa, developing drought tolerant sorghum and millet for sub Saharan Africa. In Brazil, creating heat resistant soybean varieties to cope with rising temperatures. Moving forward with the technological innovations, precision agriculture and smart farming technologies is one of the method for technological innovations, which includes precision agriculture uses technology to optimize crop management such as GPS and GIS technologies, which means monitoring field variability and apply resources more precisely. Remote sensing. Drones and satellites provide data on crop health, soil conditions, and weather patterns. Second is smart farming technologies, IoT devices. Soil moisture sensors and climate monitors help manage irrigation and other systems efficiently. Automated machinery like robotic harvesters and autonomous tractors increase efficiency and reduce labor cost. In US, precision agriculture is widely used for maize and soybean production with innovations in variable rate technology and automated irrigation. In Netherlands, smart farming technologies like climate controlled greenhouses and automated planting systems are used. Now, role of biotechnology in technological innovations include genetic engineering, which means enhancing crop resilience to climate stressors such as GMOs and gene editing. In China, developing genetically modified rice varieties that resist drought and flooding. In India, use of biotechnology to create pest resistant cotton varieties, reducing crop losses and improving yields has been done. So, these adaptations and technological advancements help farmers manage the challenges posed by climate change, ensuring food security and sustaining agricultural productivity. Moving forward with the environmental and ecological consequences of climate change, which includes soil degradation, the impact of erosion and nutrient loss on agricultural land causes soil erosion, nutrient loss. In soil erosion, it includes increased rainfall and extreme weather due to climate change lead to soil erosion, which removes nutrient rich topsoil crucial for plant growth. Causes include heavy rains, flooding, high winds, deforestation, and poor land management. This results in lower soil fertility, reduced agricultural productivity, and increased sediment in water bodies, harming aquatic ecosystems. Nutrient loss is caused by changes in temperature and precipitation accelerate the deposition of organic matter, leading to faster nutrient loss. This requires more fertilizers, which can degrade soil health further and contribute to water pollution. Essential nutrients like nitrogen, phosphorus, and potassium become depleted, affecting crop growth and making soil more vulnerable to erosion and drought. In sub-Saharan Africa region, soil erosion and nutrient loss impact agricultural productivity, with conservation agriculture being explored as a solution. In Latin America, in Andes, deforestation and intense rainfall have led to significant soil fertility declines. The second cause of climate change includes loss of biodiversity. It is a threat to a plant and animal species due to changing habitats. Climate change shift habitats through rising temperatures and altered precipitation leads to habitat loss and fragmentation. This makes it difficult for species to migrate or find suitable conditions, risking isolated populations and reduced genetic diversity. Due to loss of biodiversity, it causes species extinction. Species with specific habitat needs or slow migration rates are at high risk of extinction. The decline of key species disrupt ecosystem, affecting food webs and services. For instance, declining pollinators impact plant reproduction and agriculture. Global coral reefs are suffering from bleaching and degradation due to warmer waters and ocean acidification, affecting marine life dependent on these ecosystems. In Arctic region, melting sea ice in Arctic affects polar bears and seals that rely on ice covered waters for hunting and breeding. The third cause is water resources, which causes stress on freshwater resources and impact on irrigation. Freshwater stress. Climate change increases stress on freshwater resources by altering precipitation patterns and boosting evaporation. More frequent droughts reduce freshwater availability, impacting ecosystem and agricultural. Declining snowpack and changing rainfall patterns further strain water supplies. Impact on irrigation. Rising temperatures and variable precipitation raise the need for irrigation, putting pressure on water resources. Traditional irrigation may become less efficient, necessitating the use of water efficient technologies like drip irrigation and rainwater harvesting. In Middle East and North Africa, severe water scarcity is exacerbated by climate change, leading to heightened competition and conflict over water resources. In California, prolonged droughts and reduced snowpack strain water resources, affecting agriculture and promoting shifts in water management practices is seen. Thus, in summary, highlights the key environmental and ecological impacts of climate change, providing clear regional examples to illustrate these effects. Now, let us move forward with the solutions and patterns to change with the changing climate change. First is policy and global response to climate change. First is international agreements and initiatives. Global organizations playing key roles as United Nations, UN Framework Convention on Climate Change. This forum leads international climate negotiations. The Paris Agreement, a major outcome, aims to limit global temperature rise and build climate resilience, including impacts on food system. UN Food Systems Summit. Held in 2021, this summit focused on making global food systems more sustainable and resilient to climate change by improving food security, nutrition, and environmental impact. Second is Food and Agriculture Organization. FAO climate change strategy includes supporting global food security by promoting climate smart agriculture, improving climate impact data, and developing resilient food systems. Global Action Plan in- integrates climate adaptation into agriculture policies and promotes sustainable practices. Third is International Fund for Agriculture Development. Adaptation for smallholder agriculture program includes providing funding and support to smallholder farmers adapt to climate change, improve productivity, and manage water resources. Other key initiatives includes CGIAR research programs, which includes focusing on developing climate resilient crop varieties and sustainable farming practices. Another is Green Climate Fund, which helps developing countries finance climate adaptation and mitigation projects, include those related to agriculture. The second is national and local policy response. In Netherlands, they implemented advanced water management and agriculture policies, including flood protection system and precision agriculture. In Ethiopia, climate resilient green economy strategy improves land management, introduces climate resilient crops, and promotes sustainable water practices. In India, National Mission for Sustainable Agriculture NMSA focuses on drought resistant crops, efficient water use, and soil health management. So now further let's look into future direction and recommendations. Let us look into the future directions and recommendations as the climate changes and how we can move and work along with it. So, strategies for building resilient food systems includes enhancing adaptation measures, strengthening research and development. Enhancing adaptation measures includes diversification, promoting diverse crops and livestock to spread risk and improve resilience. Infrastructure investment, upgrade irrigation systems and other infrastructure to withstand extreme weather events. Strengthening R&D includes climate resilient technologies. Investing in research for resilient crop varieties and agriculture technologies is beneficial. Monitoring and data collection, which improves the data system to understand climate impacts and guide policies according to the collections and data. Now, importance of sustainable practices and international cooperation includes promoting sustainable practices and fostering international cooperation. So, conservation agriculture uses techniques like reduced tillage and cover cropping to improve soil health and water retention. And sustainable water management includes implement of efficient irrigation systems and water saving practices. Now, fostering international cooperation includes global partnerships. Collaborating internationally to share knowledge and best practices is beneficial for overall globe and to foster international cooperations. So now, secondly, policy alignment. To ensure national policies align with global climate goals for coordinated action is needed for fostering international cooperation. Thus, in summary, an overview of the key international and local efforts to address climate change and its impact on agriculture, highlighting successful strategies and future recommendations is necessary. To conclude the overall presentation today, it is important to understand how climate change is seriously affecting our food systems by reducing crop yields, stressing water supplies, and disrupting livestock and fisheries. Rising temperatures and extreme weather events are making it harder to grow crops and manage livestock, while warming oceans are altering fish populations and migration patterns. Soil degradation, loss of biodiversity, and increased pressure on freshwater resources are making these problems more worse. To address these issues, we need to act quickly by improving farming methods, managing water sustainably, and investing in new technologies. It's crucial for governments and international organizations to work together on policies and solutions. By focusing on sustainable practices and ongoing research, we can create a resilient food system that can adapt to a changing climate change and ensure a stable food supply for the future. Thank you.